Okay, good afternoon, everybody. Today we are moving to chapter 7.3, one sample test for the mean. One sample test for the mean. And sure, just a reminder, when we enter the second part, I mean the range for our final exam, personally, I think the level of the chapters are become more and more difficult, So I encourage you, if you have chance, you can study the text by yourself because it's open textbook. You can study it by yourself. And if you have any question you want to discuss with me, you are very welcome. Even online or on the classroom, either one is okay. I at least 4 days stay on campus, so please let me know if you want to discuss with me. Okay, let's move to the chapter 7.3. One sample test for the mean. It's the time to go back to look at the test for the mean when it is introduced in the section 7.1 called the z-test. In the example, you knew that the population standard deviation called sigma. That was what if you don't know about the sigma? Actually, in our exam about the chapter number 4, maybe number 4, we did a calculation, and now we have the chance to re-understand the importance about this one. Okay, you could just use the sample standard deviation S, italic S, as an approximation of sigma. That means this mean is not average. This means just the means. Okay. This means that test statistic is now x bar minus micro divided s per square root of n. Great. Now you can go and find the p-value using the normal curve. Or can you? Okay, it's a new test statistic normally distributed. Actually, it's not. How it is distributed, a man named W.S. Gossett figured out what this distribution is and called the student's T distribution. As I know, this guy is from British, but he worked in a German brewery, and but the moment about the business secret, thus the gentleman cannot publish the research results with the real name. Thus, he had a pen name called student. Okay. Then later we call the T distribution as student T. There are some assumptions that must be made for this formula to be a student T distribution. These are outlined in the following theorem. Note the distribution is called the student T distribution because the name he published under, because he could not publish under his own name due to the employer not want him to publish under his own name. As I know about the business secrets, okay. His employer, by the way, was Guinness and the famous brewery, and they didn't want to competitors knowing about they had a chemist working for them. It's not called the student T dispute because it's only used by students. Okay. Theorem: if the following assumptions are made. The first assumption: a random sample of size n is taken. Second, the distribution of the random variable is normal or sample size is 30 or more. Here, we need to memorize one concept that's very easy. When the sample number is big enough, generally 30, then the distribution of T equals x bar minus mean divided by n over square root of n, okay, is the student t distribution when n minus 1 for the freedom, degree of freedom. Again, degree of freedom is very, you need to study the concept, but the principle is very difficult. But you just memorize that n minus 1 is the degree of freedom. Okay, example about the degree of freedom. Recall the formula of some standard deviation. Okay, oh, sorry. I forgot to. Okay, according to the formula of some standard deviation is S, the standard deviation equals square root of sigma summation of x minus the mean, and get the square root, get the square value divided by n minus 1. Okay. Notice the denominator is n minus 1. As in our midterm, I had a question like this. Okay. This is the same as the degree of freedom. This is not accident. The result of the denominator in the degrees of freedom are both n minus 1 come from how the standard deviation is calculated. We remember, first you take each data value and subtract x bar, the mean of the x. If you add up all those new values, you will get 0. Yes, I just discussed this one with one of the students here. This must happen. Since it must happen, the first n minus 1 data value, you have freedom of the choice. But for the nth data value, you have no freedom to choose. Hence, you have n minus 1 degree of the freedom. Another way to think about it is if you have 5 people and 5 chairs, the first 4 people have a choice and where they are sitting, but the last person does not, because only one chair left. Only one chair left. The person have no choice. They have no freedom of where to sit. Only 5 minus 1, that is 4. People have freedom to choose. I think it's very symbolic explanation, but personally, I think it's okay. It's okay. And the student t distribution is bell-shaped, that is more spread out. Sorry. Than the normal distribution. There are many distributions. One of each different degree of the freedom. Here is a graph of the normal distribution here, the highest one, and the student's t distribution degree of freedom, that is 1, that is 2. When the number increases, it's approaching to the normal distribution, the plot. As the degree of freedom increases, the student's t distribution look more like the normal distribution. Absolutely, it's okay. To find possibilities for the t distribution, again, technology can do this for you. There are many technologies to do this. On this one, the software, the command line is like this. Yeah, sure, we will use another software. Or on R, the command to find the area. Okay. And here, let's check the hypothesis test for one population mean. Again, that is called t-test. And t-test, that is very important for everyone. That's very important for you. Let me show you here. Yeah, now we are on the chapter 7, and later chapter 8, chapter 9, chapter 10, and chapter 11, especially chapter 11, chi-square and ANOVA test. We will explain this. Regression is also important. We will have some hours on this. two sample interference is a little bit hard, and I will consider maybe I will teach a part of it. Oh, why no screen? Okay, let's move back here. And here, state the random variable and the perimeter in words. First, x is assume x is a random variable, and the mu, the mean of random variable. Okay, the mean, the average of random variable. Okay. Second, state the non and alternative hypothesis and the level of significance. Non-hypothesis H0, the mu equals mu 0. Okay, where the mu 0 is the known mean. Alternative hypothesis, the mu is smaller than mu 0 or none. Okay. The second one, hypothesis, mu greater than the mu 0. Okay. Use the approximate one for your problem. Okay. So use the appropriate one, or hypothesis, mu is not equal to mu 0 or mu none. Okay. Also state your alpha level here. State and check the assumption for the hypothesis test. A random sample of size n is taken, then the population of the random variable is normally distributed, and though the t-test is fairly robust to the condition of the sample size is large, this means that if this condition isn't met, but your sample size is quite large, over 30, then the result of the t-test are valid. Okay, just one concept. The sample number over 30 or equal to 30, the results of t-test are valid. And the population standard deviation, sigma, is unknown. Whoa, okay, again, population standard deviation, it means the population can be a very big, a complete one, a big one, but it's impossible. We don't have enough cost, we don't have enough time, we don't have enough technology to understand it. Thus, we try to pick up some representatives. We call that sampling. We pick up some sampling and try to calculate the samples to estimate the population. So far, there's a purpose to learn the statistics. The number 4, find the sample statistic, test the statistic, and p-value. The p-value, okay, the formula t equals this one, the numerator, the denominator, with the degree of freedom, df, degree of freedom, equals n minus 1, like this one. Okay, go ahead. Okay, number 5, this is where you write the reject H none or fail to reject H none. The rule is if the p-value smaller than alpha, generally 5%, then reject H none. If the p-value greater or equal to alpha, then fail to reject H none. This is where you interpret in real-world terms and conclusion to the test. The conclusion for a hypothesis test is that you either have enough evidence to show HA is true, or you do not have enough evidence to show HA is not really true. Okay. How to check the assumption for a t-test? In order for t-test to be valid, the assumption of the t-test must be true. Where you run a t-test, you must make sure that assumptions are true. You need to check them. Where is how you do this? For the condition and the sample is a random sample, describe a bit how you take the sample. Make sure your sampling technique is random. For the condition that a population of the random variable is normal, remember the process of assessing normality from chapter number 6. Okay, let's check the number here. Oh, okay. Example 7.3.1, test of the mean using a formula. Okay, and now a random sample of 20 IQ scores of a famous people was taken from the website of IQ of famous people. Here is a reference. And a random number generator was used to pick up 20 of them. The data are in example 7.3.1. Here, the table. Okay. Do the data provide evidence at 5% level that the IQ of a famous person is higher than the average IQ of 100? Okay. The question is, do the data provide evidence at a 5% level that the IQ of a famous person is higher than the average of IQ of 100? Okay, here is the IQ. Here's the IQ. First, state the random variable and the perimeter in words. Here, X equals IQ score of a famous person. That is the random variable. Second, state the known and alternative hypothesis and the level of significance. Okay, here H known, the hypothesis, non-hypothesis, mu equal to 100. Second, the alternative hypothesis, mu greater than 100. And the question set the alpha level as 0.05. It also means 5%. Number 3, state and check the assumptions for a hypothesis test. Okay. Number 3, a random sample of 20 IQ scores were taken. This was said in the problem. The population of IQ score is normally distributed. This was shown in the example here. Okay, then question number 4, find the sample statistic, test the statistic, and p-value. For the average is 145.4, and the standard deviation is 29.27. And test statistic. Okay, and now I need to have a short pause here, and please calculate. How can we get the number here? 145.4. Then later I will tell you how to calculate this. First of all, okay, please calculate the mean over here. Okay, I just copy and paste the number over there. Okay, please use 3 minutes to calculate the mean of the IQ from the table. And second, let's calculate the standard deviation here. There are several ways to calculate, but please do it first. Okay, 3 minutes later, I will demonstrate how to use Google Office to do this mission, to solve this mission. Hey, sorry, how about this finish this question, then we can have a 10-minute break. Okay, the first mission for you, first assignment for you, to calculate the 20 samples of the IQ here, and how to get the number. The mean is 145.4. The standard deviation is 29.27. How to get that? I encourage you to use the Google Excel, the Google Office. Questions, please let me know. Please use Google Office to calculate the mean and the standard deviation. Okay. Okay, and oh, sorry, I forgot to say that. 1 minute, please. Let me switch to. Okay, let me switch to the user interface to English. And go to the Google Drive and have a new Google spreadsheet, Google Sheets. And I prefer to name the title as Today's Date, Chapter 7.3. Okay, and my first mission to calculate the mean of that. Oh, here. And remember to copy and paste the information source. Okay, and next question. Okay. Please copy those 20 information, the total data. Okay, and here is the information. Okay, first question. After we set the IQ score is the famous person. Okay, and the mean of the first famous person. Okay, and here non-hypothesis, they are equal, no significant difference. The alternative hypothesis, they are smarter than the average. They are smarter. Okay, they are smarter. The famous person. Okay, the alpha label 0.05. It means 5%. 5%. And now, how to calculate the simple mean? 145.4. You can do that. mean, and on the next cell, average. Okay, again. Here is the original data I selected from the textbook 20 data here. And second, copy paste it to our Google Office. Then I type a mean, M-E-A-N, the average, and move to the next cell here and type the symbol of equal, type average, and select a range of this. And we got the number, the average is 145.4. Okay, it's okay to get this. Okay, then second question, how to get the sample standard deviation? An italic S. Do you remember? Okay, here sample standard deviation, I prefer to type as sample SD. That's my habit. Okay, sample SD, and click here. And okay, beware of this key point. The key point. Move to the function. Type equal, and you can select the function. Click the function. No, sorry. We select stdev.s and select the value and click enter. See, here is that one. Again, you can type the function equal st standard deviation dot s. S means sample, not a population. The range from A5 to E8. This one. Then click enter. We got the sample standard deviation. That's 29.27. About this. Okay, please do this part, then we can have a break. Yeah, again, please remember to copy and screenshot that on your notes, on your digital notes. Like this one. New post. New post. You may copy. Please remember to copy the author here. Okay, then the information is here. Then find simple statistics. Okay. And sure, you can copy paste here. Okay, is it okay? After you finish this part, you can click publish. Okay, so far any question? Okay, if no more question, have a 10-minute break, then we will discuss after we come back.